The expansion of Aitik, Sweden's largest mine, was opened in August 2010 by His Majesty King Carl Gustaf XVI. A comprehensive ABB power and automation solution, including the world's most powerful gearless mill drives, will double production capacity and create one of the most modern and efficient mines in the world. The Aitik open pit mine, located 100 kilometers north of the polar circle, produces ore containing copper, gold and silver. The project was started in 2006 and completed in the first half of 2010. Production is now successfully being run in and will achieve an annual capacity of 36 million tons of ore in 2014. Among ABB's scope of supply are two 22.5 megawatt gearless mill drives, or GMDs. The most powerful GMDs ever built that will power two new 11.6 meter autogenous grinding mills and crush up to 2,200 tons of copper ore an hour. Shipping a GMD is an engineering feat in itself. Over 15 meters long end-to-end and 2.5 meters wide, each quarter weighs more than 100 tons and is shipped separately by truck to the mine, where, once joined by other key components, the monumental task of reassembly begins. Lifting lugs are positioned in the lower and upper stator quarters. The upper and lower stator quarters are placed on I-beams, which act as temporary support for the stator quarter during transport. The stator quarters are equipped with go-through stud bolts, with a lifting lug on one side and nut on the other side for basic transport. The lifting lug on both sides are used for handling during installation. The first stage is to check the integrity of the winding, before removing the special metallic protection cover that is used to protect the windings. The stator quarters are extremely rigid, which means that during installation they are easy to handle as they do not flex or bend. Two cranes are used for turning and orienting a stator quarter, with a 120-ton overhead crane used for moving the quarter into its final position. Each stator quarter has 3 lifting lugs to lift, turn and orientate the quarter as required. One of the lifting lugs used in loading and offloading is used on the other side of the go-through stud bolts during handling for installation. An overhead crane then transports the stator quarter into its final position. Positioning of the stators is critical and as such takes time, patience and skill to maneuver each quarter into place. A skate table is used for lower stator installation, all of which is required to minimize risk and maximize safety for man and machine. 2 winches are required to turn the mill. Parts are fixed with come-along chain blocks. The stator quarters are then secured into position. As soon as quarter 1 and 2 are installed, they are bolted together. Quarter 3 is installed and will be bolted to quarter 1. Quarter 4 is installed and will be bolted to quarters 2 and 3. A temporary support is installed in order to support the 3rd and 4th quarter. Once again, using 2 cranes to maneuver the section, an overhead crane then stabilizes the quarter. Chain hoists are used to guide the 4th quarter into its final position. The ring motor's windings are designed for rapid installation at the stator joints. As such, the bottom and top bars are installed. Bars are glass fiber corded, filled with resin to stabilize the bars, brazed together, and end caps are mounted to protect the bar ends. ABB has developed an innovative way of assembling the ring motor's poles. Each pole individually positioned by using eccentric bushings to ensure a perfect circle. This ensures a uniform air gap throughout the entire circumference of the rotor, bringing greater reliability and efficiency to the machine. By mounting rotor poles directly to the mill body and surrounding it with the stator ring, the mill itself becomes part of the motor. The necessary torque to turn the mill is transmitted between the GMD and the mill via the magnetic field in the air gap between the stator and the rotor, resulting in a motor system that requires no gearing or direct contact transmission.